All right, so let's look at sulfuric acid. There's my sheet, here it is. Sulfuric acid and calcium hydroxide. So sulfuric acid is one of these ones that you need to know. H2SO4 is sulfuric acid, and we're adding that to calcium hydroxide. So if we get our periodic table, calcium here has a valency of 2+, and hydroxide, we know from our anion and cation sheet, is OH with a minus. Now calcium valency of 2, hydroxide with a valency of -1. We can do our swap and drop. So that will then give us 1 calcium, and we need 2 hydroxides. Now don't forget, we're treating that whole OH as a single compound or single element. So if we had OH and then a 2 without the brackets, we're changing that hydroxide to H2O, which is not what we want. We want OH as our formula. So we need to put the brackets around the outside, which tells us we need 2 molecules of hydroxide to bond with our 1 molecule of calcium. So let's just complete that there. All right, and we know it goes to salt and water. So let's do our H2O first. So we can get our H2O, which leaves us this calcium sulfate as the salt likely formed. All right, now we need to look at this and see if this is balanced. So I'm going to write this out again just so it's a little bit clearer. All right, so we have H2SO4 plus CaOH2 goes to calcium sulfate and water. All right, now we know that water is balanced. We can look at the sulfate, calcium sulfate here. Calcium has a valency of 2. And we look at our anion sheet here. Sulfate has a valency of 2-. So we've got 2+, 2-. So we know that that there is balanced, at least in that form there. So now we need to balance this whole equation. So we need to make sure that however many hydrogen, sulfate, calcium and hydroxide ions are here, atoms are here, they have the same number of atoms there. So let's do it this way. H equals, now we've got SO4 here and SO4 there, so we can do that as an SO4 equals calcium equals, and we're going to split this hydroxide for this purpose. Because we don't have a hydroxide unit over here, it gets bonded and split to form water. So we're going to count that hydrogen as part of the overall hydrogen, which leaves us just the oxygen from that equation to work out. And we'll do the same on this side. Right. Now, as I said before, because we've got a sulfate here and a sulfate there, that's the salt part of this. Sulfate and sulfate, we can do a sulfate group to make sure they're balanced. We've got a hydroxide here, but we don't have a hydroxide on this side. So we need to then look at the individual atoms involved, oxygen and hydrogen, to make sure that those all balance with the number of oxygens and hydrogens on that side. So let's start with our hydrogens here. So we have 2 hydrogens here, and we've got 2 hydrogens here, which gives us 4 in total. Now on this side, we only have 2 hydrogens. So let's put a 2 in front of here which will bring this up to 4. 2 lots of 2 hydrogens gives us 4 on this side. Now in doing that 2 there, we're now saying we've got 2 oxygen atoms. And if we look over on this side, ignoring the sulfate for a second, we can see we already have 2 oxygen atoms there. Hydroxide, we've got 2 of those bonding to calcium. So 2 oxygen atoms, 2 oxygen atoms. So we can say that that is balanced. All right, now, sulfate group, we've got 1. Sulfate group, we have 1. Calcium group, or calcium atom, 1. Calcium atom, 1. Good. So that now becomes our balanced equation, looking at the neutralisation of sulfuric acid with calcium hydroxide. Now, I'll leave you to do the rest of these. Now you know the basic formula of how to do it. Nitric acid, you may just need to look that up to work out what that is. That's HNO3, and remember it yields nitrate ions. If you're not sure of that, if you don't look it up, it's HNO3 is the formula. Hydrochloric acid, HCl, sulfuric acid is this one here, the H2SO4. So good luck with those. Any questions, let me know.